Poorly fitted shoes can ruin a runner's day. They can compromise the runner's gait and lead to injuries. It's why custom-made running shoes have become popular. Tailored for one specific pair of feet, they give the runner the necessary support to go the distance. Thanks to the use of synthetic materials, the running shoe is more lightweight and flexible than ever before. Customizing these shoes takes the concept one step further. They start by taking a precise 3D laser scan of each foot. Then the runner steps onto a device called a pressure plate. Rubber-tipped pins sprout up around the foot. This technique creates an exact outline of the sole, including the arch. Next, a high-pressure water jet cuts through synthetic fabric like a knife. A computer guides the cuts, following the measurements from the scans. The cutouts will be used to make the upper. That's the part of the shoe that wraps around the top of the foot. A seamstress sews together the cutouts, creating the basic shell of the running shoe's upper. Uppers come in a variety of colors, and when a shoe is custom ordered, the athlete can choose. After holes for the laces have been punched into the upper part of the running shoe, the seamstress stitches on stripes, a trademark look for the company. She sews the tongue and a fabric inner sole to the upper, using rounded stitching that will prevent fraying. The inner sole joins the two sides of the upper, and this custom running shoe is starting to come together. But this shoe needs shape and structure before it's ready to pound pavement. So the next worker inserts a plastic replica of the athlete's foot, called a last, into the shoes. She glues fabric to the heel of each shoe and then pounds and presses it to ensure the fabric adheres. Left to sit for 5 hours, the shoes conform to the shape of the custom-made lasts. But if the measurements are even slightly off, they'll scrap the shoe and start again. It's time for the foam midsoles. The worker cuts the foam with dies based on the individual's feet. The foam is dual density for maximum performance. He sands each midsole, beveling the tips. This will make for a smoother landing when the foot hits the ground. The outsoles are next. The worker sculpts these treaded rubber soles along the same lines as the midsoles, so they'll fit together perfectly. He glues the mid and outer soles together. To make sure this job really sticks, they squeeze the two soles together using a hydraulic press. In a custom shoe, the athlete can also choose the tread. A deeper tread is more appropriate for trail running, and a shallower one will grip pavement better. The worker now glues the bottom of the shoe to the top. The sole is made a little larger than the fabric upper, which allows her to fold it around the upper for a neat finish. A machine they call the claw applies pressure to enhance the bonding of the sole to the shoe. Then they insert a memory foam insole, which melds to the shape of the foot. This insole is also breathable and has been treated with an antibacterial agent. The athlete's name on the heel is the final personal touch for these custom running shoes. They've taken about 5 days to make, but they're ready for a marathon.
Socks are something we put on without thinking. But consider this. The very first socks were strips of cloth or hide wrapped around the feet. Imagine walking around in those. Thankfully, that's ancient history. And today's socks are much better for the soul. With so many styles and fibers for socks these days, it's no problem putting your best foot forward. But you have to step into this room of knitting machines to truly understand what a science sock making has become. Here's a machine with the top open so we can get a view of the knitting action. An automated whirling cylinder pulls yarn from spools through holes in metal spokes. Little hooks on the needles grab the yarn. The hooks have latches. The latches open as the hooks snare the yarn and close as they knit so you don't lose a stitch. As you can see, this machine knits socks a lot faster than Grandma, sometimes making over 360 pairs a day. As the layers are added, a sock emerges from a tube at the bottom. This knitting machine is fully computerized. It automatically switches to a different color of yarn to make a stripe or a company logo. Now the machine changes gears to make a heel. It does a half rotation instead of a whole one to knit the heel shape. The needles go up and down as the latches open, and the needles pick up the yarn, pulling it in. Knit 1, purl 2. Here it is in slow motion. This is about the speed at which a human could knit, but this machine normally runs at a speed of over 200 revolutions a minute. A tension mechanism moves back and forth, keeping the yarn from going slack and getting tangled. Now a sock shoots out of a vacuum tube, and a worker turns it inside out. She sews the toe closed and cuts off the extra fabric. Then she turns the sock right side out again, and it's sucked up by the vacuum. Next, the vacuum tube deposits the sock into a bin. The trapdoor on the end of the tube ensures that vacuum pressure isn't lost. But there's more than one way to close a sock toe, a more automated way. A worker slides the sock between two metal plates. Pressure holds them in place. Then a motorized conveyor system transports the sock to a sewing head. A blade cuts off excess fabric, and a needle goes up and down like an oil rig, stitching one row and then another as reinforcement. This automated system produces a finer seam than a sewing machine that's run manually. Now that the toe is closed, a robotic arm moves in and feeds the sock to a set of rollers. A blade pushes the sock down while the rollers turn the sock right side out. A vacuum chute fires the sock into a bin. Then it's on to the rotary dyeing machine. He loads 1,800 pairs or more depending on the size of the dyeing machine. The socks toss around in a bath of dyes, chemicals, and softeners. For athletic socks, they add antimicrobial treatment to the mix. It will help prevent fungus or bacteria that cause foot odor. Now they slide the sock onto a foot form made of polished aluminum that won't cause snags. The aluminum leg forms stretch the socks to the prescribed size as they travel down a conveyor belt into a boarding machine. The boarding machine is like a gigantic iron, and the heat seals the stretch in the nylon so the sock stays that size. Once out, a robotic arm grips the sock and pulls it off the aluminum form. It's called a stripper. Then an automated rack with protruding pins collects the socks. The worker removes them a bunch at a time, and the socks are ready for packaging. And then all you have to do is pull up your socks.